Hello and welcome to day 6 of Jamb Physics in 40 days. The Jamb Physics in 40 days is a series brought to you by Oya Learn, where we believe that when you dedicate within 30 to 45 minutes of your time daily, you will gather all the necessary skills and tools that will help you to ace Jamb Physics. So perhaps if you are preparing for the Jamb exams and physics is one of the subjects you have chosen to write, then this video is for you. So please gather around and ensure that you follow the series. You wouldn't want to miss it at all. So you can go ahead and check out the videos from day 1 up until this day 6. And don't forget to share this amongst your friends who are also preparing for the exams. I promise you, everything you get from this series goes a long way to help you score a very good mark in your Jamb Physics. Now, day 6 is about work, energy, and power. And under this topic, there are a few subtopics that you should understand as per what Jamb expects of every candidate. Number 1, you're expected to understand the concept of work, energy, and power. That is, you should be able to define what work is, what energy is, and what power is. Now, work is defined as the product of force and displacement in the direction of force, often written as work done equals force times displacement S. And you know this force could also mean mass times acceleration due to gravity. And this displacement could also mean vertical height h. So this also applies, mgh. And then as far as energy is the ability to do work. And we have two types, that is the potential energy and kinetic energy. Now, students often confuse types of energy and forms of energy. When we are saying forms of energy is when we are looking at things like solar energy, heat energy, light energy, and so on. Those are forms of energy. But as far as types go, it can either be potential or kinetic. And the popular formula you know is that potential energy is often given as mgh, and then kinetic energy is given as half mv squared. And then for power is basically work done over time taken. That is the time rate of work done if we're going to define it in words. Now, after that, you should also understand energy and our society. And what we're going to pay special interest to here is conservation of energy. Now, the law, simply put, is that energy is neither created nor destroyed, but it is converted from one form into another. So basically what it means is that in a closed system, energy is never lost. That is, we just change from one form to another. Now, putting this at the back of your mind, you know that whenever you are solving problems involving work, energy, and power, oftentimes you have to convert energy from one form to the other, and then you should know that the values are the same in each of the form, taking that none of the energy is lost to the surrounding. Once again, emphasis on the fact that in that case, it has to be a closed system. So if it is not a closed system, the question itself will let you know the amount of energy that is lost to the surrounding. Now, other things that you should also brush up on are things like dams and energy production. That is how, especially electrical energy, how it is produced, either from dynamos, from the dam systems. That is when you are using hydroelectric energy and the likes. So, and then for nuclear energy, you should be able to define nuclear fusion and nuclear fission. For fusion, nuclear fusion is when we have two nuclei and they fuse together to form a bigger nucleus. And then in the case of nuclear fission is when a bigger nucleus splits into two or more nuclei. Okay, and then you should also understand the solar energy system. That is, you should be able to define what a solar collector is and what a solar panel is. Now, this is what Jamb expects of all candidates. And there are so many questions you can get from all these different subtopics. So if you're ready now, just get your materials and then let's go on to solve some past questions on work, energy, and power. This question from the UTME 2000 says, if the force and velocity on a system are reduced simultaneously by half, the power of the system is, and we can prove by dimensional analysis that power is the same thing as force times velocity, right? So if we're going to apply this, let's see what will happen to the system. So the power of the system, initial power, let's call that P1, would then be the force of the system, so let's call that F, multiplied by the velocity of the system, V. You can call this equation 1. Now, when this is reduced by half, the force is reduced by half and the velocity by half, we would have a new power. So that would be power 2. Would then be half of the force multiplied by half of the velocity. Now, from here, P2 therefore becomes 1 times 1, 1, 2 times 2, that's 4. F V. So we call this equation 2. Now, when you look at this, we can say, but FV is the same thing as P1. So that means that P2 is 1 over 4 of P1. So we see that the power is reduced by a quarter here. So in that case, the correct option would then be option B, which says reduced to quarter. In this question, we have that a body of mass 5 kg is thrown vertically upward with velocity u. Now, at what height will potential energy equal kinetic energy? Now, in this kind of question, you have to apply the law of conservation of energy, which says that energy is neither created nor destroyed, but converted from one form to the other. So in this case, we see that when you throw it vertically upward, if this is going to be the entire path that the object is going to move through, at the top here, we're going to have the maximum potential energy here. This is where we have max potential energy. And at the bottom here is where you are going to have the max kinetic energy. And they're going to be equal at some point. So what we're going to do here is, at this point, what it means is that kinetic energy here is 0, while this is max. And here what this means is that potential energy here is 0. So at the point where everything is equal, that is, the sum should give you 0 in this case, applying the law of conservation of energy. So all we have to do is equate them. So let's equate kinetic energy and potential energy. That is, kinetic energy equals potential energy. Now, kinetic energy is given as half mv squared, so that is 1 over 2 m. Now, the v is given as u in this case, where velocity is u, so we say u squared, equals potential energy is mgh. So at this point here, see that m here cancels m, right? So what we have here is u squared over 2 equals gh. And the question is saying, at what height will potential energy equal kinetic energy? So that means when we divide both sides by g, h therefore becomes u squared over 2g. This will be the height where both of them are equal. So the correct option is D. A generator is on daily use, and in the process, 10 60-watt and 5 40-watt tungsten bulbs are on for the same time interval. The energy consumed daily is, now when you look at the options provided, you see they are in kilowatt hour. So that is, we're going to use our time in hour and we're going to use our power in kilowatts. Now please take note of this, however, that sometimes you may have to use your time in seconds. But if you are calculating the cost of electrical energy, most times it is done in kilowatt hour. So, solution. Now, we know that energy is power times time, since power is energy over time. So, in this case, let's find the total power first. That will be, now from the question, we have 1060 watts. Okay, that will be 10 multiplied by 60 watts plus 540 watts. So that's 5 times 40 watts. Now this would give us, here we have 600 watts plus, and here we're going to be having 200 watts, which gives us a total of 800 watts. Now to convert this into kilowatts, you divide by 1000. That is, power is 800 watts over 1000, and that will give you 0.8 kilowatt. Now energy. The energy consumed is the power, which is 0.8 kilowatt times time. Now in this case, we'll be doing time in hours. And since it's on daily use and we are only calculating the energy consumed daily, that is energy consumed in one day. A day consists of 24 hours. So when we multiply this, we're going to have 19.2 kilowatt hour. So the correct option is option D. This question from the UTME 2009 says, if a cage containing a truck of coal weighing 750 kilograms is raised to a height of 90 meters in a minute, what is the total power expended? Okay, so to find power expended, we apply this equation. Now, power equals work done over time taken. Now, let's look at what we have from the question. From the question, we have that the mass is 750 kilograms. We also have that the height it is raised to is 90 meters. And the time it took, T, is 1 minute, which is actually 60 seconds. And we are also given a hint where acceleration due to gravity, G, is given as 10 meters per second squared. Now let's apply it in this formula. So the power expended will then be, now work done, which is mgh over time taken, T. Now M, 750 times G, 10, times H, 90, all divided by T, which is 60. Now this would give us, when you compute this with your calculator, you get 11,250, and the unit of power is watt. Now when we look at the option, we see that it is provided in kilowatts. So we have to convert this to kilowatts by dividing it by 1000 watt and multiply that by 1 kilowatt. So watts cancel watt. Final answer, power equals 11.25 kilowatt. So the correct option here is option C. If a load of mass 10 Newton stretched a cord by 1.2 centimeters, what is the total work done? Now, before I go on to solve this question, if you're yet to subscribe to the channel, I would like to encourage you to please do so. When you subscribe to the channel, you are helping us to be able to create more helpful videos like this. So please do subscribe to the channel and also click the notification bell icon, so that every time we put out a new content, you will definitely be alerted. And also do not forget to also download the Exam Fun app, an app that is available on the Google Play Store or the Apple Store, where you can make your learning experience also fun by practicing quiz on different subjects of your choice, and you earn just as you learn. So please do so, subscribe to the channel and also download the Exam Fun apps. Thank you. Now, to solve this problem, let's pick out the parameters we have. Okay, we know that this cord is stretched by a force 10 newtons, so F is given as 10 newtons. And from the question, we can see that the cord is then extended by a length 1.2 centimeters. So let's call that extension E, 1.2 centimeters. Now, this is not the correct SI unit for length, so we have to bring it to the right SI unit, which is in meters. And that would be 1.2 divided by 100. And that will give you 0.012 meters. Okay? And to find the work done on an elastic string, the equation is given as average of force, that is half force times extension. However, if you're using the Hooke's law equation, where we have F equals KE, this is the Hooke's law equation. And if we're using this, you know you can replace F with this here. That would then give you that work done equals half KE squared. So either of these two can actually work. But because we have the force here, I will go on to use this. So what we have now is 1 over 2 F, which is 10, multiplied by extension 0.012. Now, when you multiply this together, what you are going to get is 6.0 times 10 raised to the power of negative 2. And work done is measured in joules. So the correct option here is option A. This question says that an electric heater rated 220 volts and 1000 watts is immersed into a bucket full of water. So we have to calculate the mass of the water if the temperature changes from 30 degrees Celsius to 100 degrees Celsius and the current flows for 300 seconds. Now, we see that there is an electrical method of determining the specific capacity of a liquid here in this question. And what we should know from that is that for electrical method, the electrical energy heat, the electrical energy in form of heat is given as the power times time. And from method of mixtures, we also know that heat energy is given as mass times specific capacity times change in temperature. So when we equate these two together, we'll have power times time equals mc delta theta. So since we are looking for m, make m the subject, m becomes power times time over specific capacity times change in temperature. Now the power is given as 1000 watts. Multiply that by the time, which is 300 seconds. Divide all of that by specific capacity, which is given as 4200. Change in the temperature. Now from 30 degrees to 100 degrees, that will be 100 minus 30 to give you 70. Now when we compute this, we are going to have 300,000 all divided by, now when you multiply this, you get 294,000. And when you divide, you come up with 1.02 kilograms. So looking at the options, that is option C. A device that converts sound energy into electrical energy is, now in this case, when we look at the options, we just have to find out which of them will convert a sound signal into an electrical signal. So starting with option A, we have the horn of a car. Now, the horn of a car actually converts electrical signal into sound, not sound into electrical signal. So it's not the answer. Option B says an AC generator, and this one's converts a mechanical motion. It first converts a chemical combustion into mechanical motion, and then that into electrical signal. So it is also not the case here. And then option C is a microphone which receives sound signal and converts that into electrical signal that is taken to the amplifier so that it could be amped up. So in this case, yes, it is actually converting sound energy to electrical energy. So the correct answer is option C. Let's solve this 2021 UTME question that says a lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meters per second into a block of mass 0.95 kilograms. Now, given that the lead block can move freely, find the final kinetic energy after impact. So we're going to start by applying the law of linear momentum. So, and that states that m1u1 plus m2u2 equals m1 plus m2 in brackets multiplied by the final velocity. So in this case, m1 is the mass of the bullet, so 0.05 times the initial velocity of the bullet, 200, plus mass of the lead block, 0.95, multiplied by initial velocity of the lead block. Since it's stationary at initial, that will be 0, equals, now we add the two masses together, 0.05 plus 0.95, and then we multiply that by V. Now here, this is going to give us 10, this is 0, equals, this is 1, so 1V. So our answer is that V is 10 meters per second. Now, to find the kinetic energy which the question is requiring, kinetic energy is half mv squared. So that is 1 over 2 times the mass. When we combine mass, that is 1.0 multiplied by v squared, so 10 squared. When we compute this, 10 squared is 100. 100 times 1 is still 100. So 100 divided by 2, and the final answer is 50. Energy is measured in joules. So looking at the option, the correct option is A. A ball of mass 0.1 kilogram is thrown vertically upward with a speed of 10 meters per second from the top of a tower 10 meters high. Neglecting air resistance, its total energy just before hitting the ground is... Now, to solve this problem, the first thing we have to do is find the maximum height of the ball above ground level. Now, take note, it already has an elevation of 10 meters already, because it is from the top of a tower that it is being thrown. So whatever we get as the height, we have to add 10 to that to get the height above ground. So, solution. At max height, V equals 0. So when we apply V squared equals U squared minus 2GH, which is the third equation for motion under gravity, we can use this to find the height. And that will give you U squared over 2G. That is because V is 0. So at this point, what we have is U, which is 10. So we square that over 2 times 10. So what we have here is 100 divided by 20, and that is going to give us 5. So 5 meters here. So total height above ground, H, would then be 10 meters plus 5 meters, and that would give us 15 meters. And we know that when you launch something vertically upward, at the top here we have the max potential energy. And here is where we have the max kinetic energy. And so we are looking for the total energy just before hitting the ground. So at this point here. So, and we know that at this point what we have is kinetic energy plus 0 equals potential energy. So basically, we can just calculate the maximum potential energy. So the energy there becomes mgh, which is the mass, 0.1, times g, which is 10, times h, which is 15. Now, 0.1 times 10 will give you 1, and 1 times 15 will give us 15 joules. The correct option is option C. A car of mass 800 kg attains a speed of 25 meters per second in 20 seconds. The power developed in the engine is... Solution. Now, power equals work done and over time taken. So in this case, we're going to be having m then v squared over t. So the mass is given as 800 times v squared, so 25 times 25, all divided by t, which is 20. So the power in the engine would then be, from here 0 cancel 0, 2 here 1, 2 here, what we have is 40. So 40 times 25 times 25. Now when you compute this, you would get 2.5 times 10 to the power of 4. And power is measured in watts. So the option we'll go for here is option B. This question from the 2022 UTME says, the potential energy in an elastic string of force constant K, which has an extension X, is, now, the energy or work done in an elastic string is given as the average of the force times extension. But we know that F equals to KE according to Hooke's law. Okay, so when we substitute KE here, we then see that the potential energy becomes 1 over 2 KE multiplied by E. So what we have is half KE squared. And according to this question, the extension E is given by X. So therefore, we can say the potential energy is half kx squared. So the correct option is option C. A train of mass 160 kg attains a speed of 25 meters per second in 20 seconds. The power developed in the engine is... Now, to solve this, we're still going to apply the formula where the power equals mv squared over t. Now, the mass is given as 1,600. Multiply that by v squared, so 25 times 25, all divided by the time, which is 20 seconds. Now, power therefore becomes 0 cancel 0. 160 in 20, that will give you 80. So 80 times 25 times 25 would then give 50,000. And since we are looking for power, power is measured in watts. But the options provided are in kilowatts, so we have to divide it by 1,000 to get our answer in kilowatts. So power then becomes 50,000 watts divided by 1,000, and that will give us 50 kilowatt, which is the option in D. Now this question says, how much work is done against the gravitational force on a 3.0 kilogram object when it is carried from the ground floor to the roof of a building, a vertical climb of 240 meters? Before I go on to solve this question, if you're yet to be subscribed to the channel, please hit the subscribe button. It's only going to take a second of your time. When you subscribe, you are helping us to be able to make more helpful videos like this. So please subscribe and hit the notification bell icon so that you get alerted every time we put out a new content. And also, you can also download the Exam Fun app that is on the Google Play Store and the Apple Store. Download, register, and have fun while you learn. Take quiz on any subject and earn as you learn. Thank you very much for doing this. Now, to solve this question, let's see what we have. The mass of the object is given as 3.0 kilograms. And it is to go a vertical height of 240 meters. Now, taking gravitational acceleration g as 10 meters per second squared, we can then go on to find the work done. Work done would be m Now m, that is mass, 3.0 multiplied by g, which is 10, multiplied by h, which is 240. Now this is going to give us 7,200, and work done is measured in joules. But when we consider the options here, we see that the answer is in kilojoules. So we have to bring this to kilojoules also. And we do that by dividing it by 1,000. So our answer would then be 7.2 kilojoules. The correct option is A. Under which conditions is work done? So let's look at the conditions we have here. A man supports a heavy load on his head with his hands. B, a woman holds a pot of water. C, a boy climbs onto a table. And then D, a man pushes against a stationary petrol tanker. Now, for work to be done, a force has to be applied on an object that will then move it a certain displacement in the direction of force. So when we look at all of these conditions that we have here, in case 1 here, you see there is no movement, no displacement, so no work is done. In B, the woman is holding a pot of water. She doesn't take it from any point to any point, so no displacement, no work is done. But C, the boy climbs onto a table. That is, he moves from the ground to the top of the table. So in this case, there is displacement, so work is done. And when we check option D here, the man pushes against a stationary petrol tanker, no displacement, so therefore no work is done. So leaving the only correct condition here, option C. So we go with that. Using the diagram above, the effective force pushing it forward at an angle of 60 degrees is, so looking at the diagram, we're told that the angle is 60 degrees. So now the force required to push this trolley will be in this direction. So, and that will be the horizontal component of the force F. So let's solve. Horizontal component X of force is given as F cos theta. So F of X is therefore, the force is given as 50 newtons multiplied by cos 60 degrees. This will give us 50 newtons multiplied by 0.5. This is 50, so 50 times 0.5 will give us 25.0 newtons. So the correct option is option A. Now folks, I believe with the examples we've solved so far, you too should be able to solve as many problems on work, energy, and power. So feel free to try out yourself, test your skills by solving problems on the Exam Fun app. It is available on Google Play Store and also in the Apple Store. So please download, register, and have fun as you learn physics. Please be rest assured we have other subjects also on the Exam Fun app. So if you want to practice with mathematics or any other subject of your choice, you will find them on the Exam Fun app. And also do not forget to subscribe to the Oya Learn channel. Subscribe and also click the notification bell icon so that you get alerted every time we put out a new content for you. And while you're solving your problems, any problem on physics at all, if there's anyone you would like us to shed more light on, please put it in the comment section, and we promise to definitely attend to every one of your comments. So thank you, and I'll be seeing you in the next video.